Hello and welcome to JavaScript Obfuscation, the continuation of our previous video on HTML smuggling. In the previous video, we discussed the capabilities of HTML smuggling, including its benefits over traditional payload delivery mechanisms, i.e. email attachments, and how to develop our own smuggling payloads. Whilst we achieved the functionality we were after and improved our methods of payload delivery, our offset considerations were minimal. The complete source code was decipherable by any median defender, meaning that if one managed to get a hold of our source code, a defender would most likely be able to implement defenses around it. Now, there are numerous offset considerations we can take into account when developing such payloads, with one of the most common one being source code obfuscation. When we obfuscate our payloads, not only does it add to an analyst to-do list to decipher that payload, which by the way can take a significant amount of time, but it also offers the benefit of being able to evade some defensive solutions, as some implementations may find it hard to de-obfuscate the payload. Therefore, in this video, we will focus all our attention on obfuscating our previously crafted HTML smuggling payload. As per usual, everything we teach in this video is purely for educational purposes. We take no responsibility for your actions. So before we delve into payload obfuscation, we best understand what it really entails. At its fundamental level, payload obfuscation is the process of making a payload more obscure and difficult to understand through the use of convoluted code. Essentially, it is the process of taking some source code and performing modifications in such a way where the original source code is still capable of executing its intended functionality, but its contents are structured in such a way that it becomes almost indecipherable. Now, such obfuscation can be done in many ways, including the randomization of variable and function names, dead code injection, where we supplement the source code with decoy code to confuse the analysts, domain locks, where we restrict the code to only executing on specified domains, and much more. Do not, however, misinterpret that just because a payload is obfuscated, it cannot be de-obfuscated, especially when payloads are obfuscated in high-level languages, such as JavaScript in this case. These payload contents are often directly visible to the analysts. Therefore, an analyst can use various automated tools in an attempt to de-obfuscate them. For compiled binaries, this process is far more advanced as it requires strong reverse engineering skills. However, that is out of our scope. The main thing to note here is that our payloads are not bulletproof to deciphering. However, it can require a significant amount of time as well as expertise from those analysts to decipher. There are numerous tools that allow us to obfuscate payloads, each with their own set of capabilities. In this video specifically, we will take a look at JavaScript Obfuscator, which is by far the most common and feature-rich. It is a command line based tool. However, there is also a web-based interface that offers the same capabilities but with an interactive interface. I recommend that you take some time after this video to check it out. With that said, let's install it and take it for a spin. Now then, you can find JavaScript Obfuscator on GitHub. It is an open source tool, and I'll leave a link to it down in the description below. But if you want to also, you can again use that web-based interface if you prefer. And every single technique that we teach today using the command line based tool works the same with the web-based interface. You'll simply go down here, select the options that you want enabling, and then once done, you'll simply select obfuscate. So there are several ways we can install JavaScript Obfuscator. We can either do so through yarn or we can do so through npm. We will take the npm example, but before we do so, actually we need to install it. Now, if you already have it installed, simply run it with the vswitch and it should print your version. In our case, it is not installed, so what I'm going to do is use sudo apt install npm. Okay, and once npm is installed, we can simply rerun it with that vswitch again and it should print out its version. Perfect, so going back into the repository here, copying the command, and I'll actually remove this save dev switch and I'll replace it with the G switch. And what this will do is it will install the package globally, meaning that we can simply run it from anywhere. Okay, so pressing enter, the installation should begin. And you should run it as sudo, as otherwise you'll get an installation error. Perfect, so once it's installed, you can simply run JavaScript Obfuscator with the vswitch, which should print out its version. And in our case, the version is 4.2.1. Now, before we continue, I just quickly want to show you the structure of how we will be hosting our payload. So if we list the contents, you'll see that we have 3 fundamental files. Now, the index.html file will be the file that is being served to the victim. So if we actually open this up, you'll see that here we have a few meta tags, we've got a body tag, and then we've also got a script tag. Now, this script that we are serving contains the entire implementation of our HTML smuggling payload. So if we take a look at the script again, you'll see that here we have the same function definition that we discussed in the previous video. And then going down here a little, we have the payload that we are serving. And then lastly, we have the implementation of automatically triggering the download. Okay, so I hope that makes sense. And to confirm that everything is working as expected, we are going to start a Python HTTP server on port 80. Go back into our browser, refresh it, and the download initiates successfully. Now, to list all of the options that JavaScript Obfuscator supports, we can simply use the H switch. And if we press enter here, you'll see an abundant amount of switches or options or techniques that the tool supports. Now, the GitHub repository defines these same set of options, but I typically prefer using the repository rather than the command line for this. And the reason being is that it simply describes each option in more detail, including any side effects that an option may have. Now, we'll get into each of these options shortly, but the first thing I want to discuss here is the presets. Now, JavaScript Obfuscator defines 4 different presets, and each of these presets define the different techniques that are implemented within the final payload. So you've got the high preset here, you've got the medium preset, you've got the low preset, and then lastly, you've got the default preset. Now, the default preset will be used every time you run JavaScript Obfuscator, but in the case that you might want to specify a different preset, you can simply use the options preset switch. So here we can see we've got the default preset, we've got the low, medium, and high preset options. Now, when using JavaScript Obfuscator, we will have to specify 2 set of options. The first option will be the script that we want obfuscating, and then the other option through the O switch will be the script that will contain the obfuscated payload. So let's just name that as obfuscated.js. So running this command, the default preset will apply, and then we should have a newly generated payload in addition to the original. Now, because our index source file is using the script payload, the original payload that is, we will simply have to replace that with our obfuscated payload instead. And then starting a Python 3 HTTP server. If we refresh our page, you'll see that the implant payload successfully downloads. Okay, so let's actually take a look what the obfuscated payload looks like. If we use Vim here and open the obfuscated payload, you will see that most of what is presented is simply unreadable. The formatting is off, the variables are renamed into something totally random, and so are the functions. Now, just by looking at this, can you tell me if you're getting overwhelmed? Because I know that I am. And you know, a beginner blue team operator or a beginner analyst looking at this might be confused immediately. Without the proper tools, decoding something like this is so hard. Now, we can actually view a pretty output of this by using the developer tools. So we'll click inspect, go into the debugger option here, and you'll see here we have our obfuscated payload. So as you can see here, it's totally random, but if we use the angled brackets here, the source code should be automatically formatted for us. And just by looking at this, it is just garbage. You know, I can't understand a thing that is going on here. But in the background, our payload is still being executed whilst providing this job to deobfuscate for the analyst. Okay, so where we use the default preset, we can actually specify any other preset by using the options preset switch. And if you recall, you'll have to specify the type of preset that you want. Now, when using the high preset, do bear in mind that, you know, the payload can become unstable. And this is because the amount of techniques that are being used for obfuscation. Essentially, it can break your payload if you're not careful. And this has happened many times for me before. So let's actually test it out. We'll use high-obfuscation, press enter here. And we will once more start a Python HTTP server. And if we refresh our page, fortunately, the download still proceeds. But whenever just using the high preset, do bear in mind that it can fail. And for the optimal balance between obfuscation and performance, I would recommend you use the medium obfuscation preset. Otherwise, just leave it as default. Now, perhaps one of the most useful option is dead code injection. And essentially what this is the addition of decoy code within the final obfuscated payload. And this is useful to throw off analysts, as when the analyst analyzes the source code, they won't be able to figure out what functionality is actually being implemented and what functionality is a decoy. So if we actually take a look at the example here, you can see some function definitions, if statement definitions, some console logs, the definition of a variable. In this case, it is an array, more function definitions, more if statements, and an analyst that is looking at this hopefully should not be able to piece together the functionality of the original payload. Now, to use dead code injection, we will simply use dead code injection switch with the value of true. So by running this and going back to our server, if we refresh this now, the download still continues. But now if we take a look at the developer tools once more, go back into the debugger, you'll see that there are numerous function definitions here that simply don't make any sense. More specifically, here is a function. I'm not sure what it does, but it seems to define several variables within a try catch statement, and it seems to possibly return some values. But as you can see here, it is way harder to determine what is going on than the default obfuscated payload. And keep in mind, the default preset actually does not include dead code injection. Now, another option that is useful is string array. And what this does is simply remove string literals and replace them in a special array. So as you can see here, the string hello world in the variable m as defined hello world will be replaced with something like this. Really confusing. I don't even know what to use as a description for that. Now, by default, you will note that this option is already enabled. So we don't actually have to manually specify its enablement. But by using string array encoding, we can encode those strings in base64 or RC4. So this will essentially make it harder to determine what these string contents are. Now, to use string array encoding, you'll specify the string array encoding switch, and then you'll specify either base64 or RC4. Now keep in mind that if you are using RC4 encoding, it can make your code up to 30 or 50% slower. But then the benefit to this is that it is harder to get the initial values. In our case, we will simply use base64. Now, if we take a look at the size difference here, you'll see that the obfuscated payload is 27 megabytes, and then the original payload is 21 megabytes. So it has increased in size, and mainly because we are using string array encoding. Okay, so let's go back into our web server, refresh it again. So it is taking significantly longer, but as you can see here, the payload still downloads correctly. And if we take a look at the developer tools again, go into the debugger section here. As you can see here, looking at the source code, many of these string arrays are indeed encoded in base64. Okay, and one of the last options that we will discuss is the numbers to expressions option. And what this will do is simply convert a number into its expression equivalent. So as you can see here, the number 1234 or 1234 in its expression format looks like so. So in the cases that your payload originally has a lot of numbers and you're dealing with a lot of numbers, you can use the numbers to expressions option to make them even more hardly readable. To use this option, we simply use the numbers to expression switch with a value of true if we want to enable it. And if we go back into our web server, refresh it again, the download still succeeds. And if we actually take a look at the developer tools once more, you'll see here that many numbers are instead used as expressions rather than being used as numeric literals. So we've got some examples here as well. Going down here as well, we've got some examples. Here we got the definition of a variable, and it's using an expression to store a value, and much more, as you can see for yourself. Now, I know I said that we would get into link triggers and ISO images in the previous video. However, after some reflection, I thought that including the concept of JavaScript obfuscation before we get to that topic was important. Moreover, I've decided to include a video on the concept known as mark of the web, as it is really important to understand when dealing with payloads that are downloaded over the internet which we will explore in great detail in the next video. In this video, we covered the fundamentals of JavaScript obfuscation, which is an excellent OPSEC precaution we can take when developing such payloads. I suggest that you have a play around with the various other features and capabilities that it supports, as the tool we discussed is far greater than what we've covered. With that said, I hope you've enjoyed it. If you did, please drop a like as it does help us grow. Furthermore, we have a growing Discord channel where you can join to chat, contribute, make some friends, and soon get involved in an entirely Discord-based virtualized lab environment where you can upgrade your skills in every facet of cybersecurity. Until then, keep learning, and I hope to see you in the next one.